Hello, everybody. I'm Andrew. Thank you very much for that introduction. So my talk is about HTTP headers, about which I have something of an unnatural obsession. When Uncle Tim invented the web back in 1991, HTTP was pretty simple. We would say get, and we would say the thing we wanted to get, and we would say which protocol we wanted to use. I'm actually using HTTP 1.1 here, which was standardized in 1997 before anyone starts tweeting at me. The host header tells the server which website we want to get to the document from, so we can host more than one website on the same server. This makes sense. And in the response, we're saying, OK, I agree to use the same protocol that you wanted, and this request succeeded. Here is a document that I generated on this date. It's of this type, and it's this long. This makes sense. This is what it looks like today. So did we go wrong somewhere? Or is all of this really necessary? Is this adding to our security? Is this adding to our performance? Do you know what any of this means? Are there things not in here that should be in here? Are there things in here that shouldn't be in here anymore? So I'm hoping to help you to answer some of those questions today. I used to be a member of the tag. I'm afraid I am actually no longer a member of the tag as of January. But the tag is a 9-person group that is like the sort of stewardship council for web standards. So if a working group wants to add something to the web, they will suggest that feature. Oh. There we go. In a pull request or an issue on the repo, and the tag will then look at that spec and try and put it in the context of web architecture and say, is this the webby way of doing things? Is this compatible with other things that we're adding to the web platform? Is this in the interest of the users? And then we provide feedback back to the group. And I was finding that a lot of the things that we saw over the last couple of years that I was in the group were headers. They weren't the normal things that you expect to get added to the web platform, like JavaScript APIs or HTML elements. So this is going to be a problem, isn't it? So here are some of the headers that we looked at over the 2 years that I was on the tag. And I'd love to see a show of hands of everybody who's heard of all of these HTTP headers. And I see no hands. And that's not surprising, because if you've heard of all of these, then that probably means that you work in standards, because none of these are actually supported by browsers today. But they're all coming down the pipe, or at least may be coming to a browser near you soon. So it's as well to understand what they do and how they might influence the way that you build websites in the future. For this talk, I also did some research using HTTP Archive, which is a Google project that loads the Alexa top 1 million websites every 2 weeks, puts them through web page test, and then puts the entire waterfall results into a BigQuery database. BigQuery is really cool. It's a Google product, but they make it available for free for the HTTP archive. And it essentially allows you to run SQL queries on the raw data of the web page test results. So I can do this, and I can literally graph HTTP response headers by popularity. And this reveals some really surprising results. Some of them are way more popular than you'd expect them to be. Some that are really useful and help us to keep our sites secure and more performant are not there at all, and really should be more popular than they are. So I want to today look at the headers that we don't want and the headers that we do. And we'll start with the ones that we should be seeing far less of. And I'm going to start with P3P, because this is the first header that I found on the list that I didn't recognize. I thought, oh, I don't actually know what that does. So who does? Who knows what P3P is? Very, very few people. That's actually a really good result, because the most common value for the P3P header is this is not a P3P policy, which brings this to mind for me and makes me think, well, is it or isn't it? And if it isn't, then why is it here? And the story here is that it is something called the Platform for Privacy Preferences project. And it is intended as a declaration of a machine-readable privacy policy. And I actually think this is a really good idea. In fact, it sounds a lot better than what we've ended up with the likes of EU's cookie directive and GDPR. But it didn't work. It was considered to be too hard for users to understand and use, and no user agents ever surfaced this information visually to the user in any way. The only thing that the only integration that it did make, it did end up having into browsers, was that Internet Explorer used it as a gate for accessing third-party cookies in iframes. So if you didn't have a P3P policy, you couldn't access those cookies. But it didn't matter what the policy was. So you could set it to, this is not a P3P policy, and that would satisfy the check just fine. So don't use P3P is the verdict there. Now, from P3P, let's go to expires, which is kind of the opposite end of the spectrum in that almost everyone in this room, I'm sure, knows what expires is. And it's being emitted by 80% of sites in the archive. So why is this a bad idea? It works. It's supported by all browsers. Almost all of them are Thursday, the 1st of December, 1994 at 4 p.m. Hang on. Why is that? Why does everybody set their expires date to the same date, which is years before the expires header was ever even invented? Anyone know the answer to that? Shout it out if you do. OK. It's in the spec. It's the example in the spec. So why does everybody copy the example in the spec? Well, I have a pet theory, which is that the HTTP date format is actually a crazy date format that includes the day of the week for no readily apparent reason. So if I wanted to pick an arbitrary date in the past and format it correctly using HTTP date, I need to know what day of the week it was. And because I'm unlikely to know that, it's easier just to copy the example from the spec. But if I do that, then next to that example, I will see this text. If a response includes a cache control field with the max age directive, that directive overrides the expires field. So it overrides the expires header completely. So obviously, there is no one who is serving both a cache control header with a max age directive and also an expires header, apart from, all of these people. 64%, in fact, of the sites that emit an expires header also emit a cache control header with a max age field. So you don't need it. You can get rid of it. If you want something to not be cached, just cache control private no store. No store says browsers won't store it, and private says that shared caches like CDNs, like Fastly, which I work for, will also not store it. So speaking of CDNs, I want to talk about a header called xcache and friends, because this header is actually not a real header at all. It's not in a spec. It's not written down in a standard. It's not supported by any of the browsers. And yet, almost 15% of sites on the internet are emitting it. And seemingly, they all agree on what it means, because they all set it to the word hit. So what does this mean? Well, it's actually our fault, to be honest. People don't set this header themselves, but if they use a CDN like Fastly, then we add this header on the way through our network to indicate whether the object was a hit in the cache or whether we sent it back to the origin. And this is pretty useless for end users. Like, no end user needs to know this information. Their browser is not listening for it, and it's not doing anything with it. So actually, it would make much more sense for you not to see it in the browser at all unless you're the developer of that website. And it's in good company. Like, these are all of the headers, or a very small number of the headers, which I found in HTTP archive, which don't mean anything to browsers. Some of them are vanity headers, like xgenerator or xgenerated by or server. I mean, obviously, if you want to tell people what server software you're using, that's great. Doesn't mean anything to the browser. Some of them are debugging information, like xRequestID. That's probably quite useful to you if you're the developer, but it's not useful to you as an end user. And some of them are just spurious information that we don't need. In some cases, I found request headers like host being re-emitted into the response, which is almost certainly a bug. So if you're using some kind of caching proxy in front of your web servers, like Varnish, for example, you could write some VCL to suppress these debug headers unless some specific condition is met, like some kind of debug inbound request header is present, or a cookie, or a query string parameter, or something like that. Anyway, X-frame options. X-frame options is cool. This is quite useful for doing something that is completely reasonable, which is preventing third-party sites from framing your site. Why would you want to do this? Well, if you put another site in an iframe, make that iframe invisible, then you could potentially trick someone into clicking a part of that site that they don't intend to. This is a practice called clickjacking. And so X-frame options was invented as a defense against that attack. As a result, this is very popular. Almost a quarter of the web is setting this header. It's almost always set to the word same origin, which only allows pages from the same origin to be framed. So this is a good thing to do, but this is not the correct header to do it with, because there is a directive within the content security policy framework called frame ancestors. So this is better for two reasons. The first one is that you should already have a content security policy, as I'm sure everyone in this room does. And secondly, frame ancestors is much better specified than the X-frame options header, so you will get more consistent behavior across browsers. And finally, I want to talk about via. So via is a header that is set by proxies, both on the way in. So if you go via some intermediate system before you end up at the origin, then a via header will be added on the way, and also on the way back. So you can get an idea. Let's assume we're using Fastly as an example. On the way in, we will set a via header, and on the way out, we will also set a via header. Now, the request via header is actually really important, because setting it means that we record that we have processed this request. So if the request comes back again, we know that we're in a loop. So if, for example, you had a Fastly service with another CDN as set as its backend, and that CDN had the Fastly CDN as its backend, then we don't blow up the internet, because we use the via header to determine that we are in a loop. But that said, that's only the request header. The response header is not used for this purpose. It's purely informational. We can remove it if we want to, and there's no impact to doing that. So those are all the ones I'd like to see less of. Let's talk about the headers I'd like to see more of. So the first one, and most obvious one, and we heard quite a lot about this earlier on, is content security policy. But as we heard earlier on, it's hovering at a very, very low adoption rate. And one of the reasons for this is that it's pretty hard to create a content security policy which works for your site for a long period of time, because you're likely to adopt new third-party scripts or invent some new host name somewhere, and you're constantly going to need to update your CSP. So the example that you see for CSPs in things like Mozilla Developer Network are somewhat unrealistic, because I very rarely see a CSP in practice which is this succinct and this brief. In practice, what CSP does is it provides a kind of firewall in the browser which activates as soon as the page loads. So the initial page load is not subject to a content security policy, but any requests made by that page, say for images, style sheets, or AJAX calls from the page, are subject to the rules in the CSP. So if you were to add a new analytics provider, for example, you might need to add a rule to your CSP to allow that connection to go through. Otherwise, it would be blocked in the browser. For this reason, a lot of people actually automatically generate their content security policies. And this is a really bad idea, because it means you end up with a content security policy like this, which is a small part of the largest CSP which I saw in HTTP Archive, which was almost 10 kilobytes in size. And that is terrible, because given sort of a normal conditions of congestion control and slow start, you would probably find that you wouldn't get any content at all in the first round trip between client and server if you're serving a header of this size. So don't do that. Don't automatically generate your CSP, or at least don't automatically generate your CSP and then not inspect it afterwards. So another header which also contributes to security and which is much simpler to implement than CSP is strict transport security, or HSTS. This very simply tells the browser that your site should always use TLS. Now, of course, end users do not type in https:// before they type the address of the website they want to go to. So they'll type your address just as a domain name. And then the browser, because it has to be backwards compatible, will connect to your website over HTTP. And then your web server, because obviously your web server only is willing to talk TLS, will redirect the user to the encrypted version. So this has two problems. One is that it provides a window for an attacker to intercept that connection. Even though there's only one round trip, it's still unencrypted. It can still be intercepted. And the second is that you're suffering a performance penalty. You have to do a redirect. And we don't want to do that redirect. So strict transport security, simply with a max age directive, will turn that on for you. Now, a referrer policy is less about security against intrusion and more about preventing exfiltration of data. Since the very beginnings of the web, we've had this header called referrer, which is set by browsers when people make requests as a result of clicking a link from one page to another. And it tells the page that you're linking to where you came from. And this used to be very useful for things like analytics before we sort of switched to mostly cookie-based approach for that. But we still send the referrer header in all outbound links from your website. And if your site has, say, a search page, and when I type in a search query and I press enter, you load a URL that includes that search query in a query parameter, which is pretty common. So say example.com/search, query equals cute puppy photos. And then you click on an external link on that search result page, then the site that I'm going to will know what my search term was on the site that I came from. And you may not intend that to be the case. And if you store any personal data in query string parameters, things like email addresses, phone numbers, dates of birth, that kind of thing, then this can be really bad. So my recommendation is that you use origin when cross-origin. This is a nice, simple policy which will still give you the full referrer information when you're linking internally within your domain, and it will send only your domain name when you're linking externally. And that's usually fine unless you've generated some kind of personal host name per user that has some personal data in it, and why on earth would you do that? Now, I think it's worth mentioning CORS because that came up at the very beginning in the intro. So all the headers that begin access control star belong to a family of headers that we call cross-origin resource sharing, or CORS. Now, the most secure way to configure CORS on your site is not to use it at all, because anything you do with CORS is going to make your site less secure. But it is still a useful tool, because in many cases we do want to be able to reach out from one domain to another in order to do useful things and provide the user with good services. So this family of headers, allow origin, allow credentials, max age, expose headers, allow you to quite minutely control what is allowed to happen between two foreign origins that do not share the same domain. Now, interestingly, on the tag, one of the biggest issues and the most long-running issues we had over my tenure was the debate over whether CORS, and specifically the idea of credentialed requests, was contrary to web architecture. And this is an issue that got raised before I joined and is still open. So I guess I didn't help to fix that one very much. But Tim Berners-Lee had a big issue with the way that CORS deals with credentialed requests. And I didn't really understand it initially because I'm not Tim Berners-Lee, but I finally think I figured it out. So the idea of the web is that URLs identify things, and all you need to know in order to fetch something is its URL. CORS makes that not entirely true. So we can make a request from JavaScript using fetch, what used to be called XML HTTP request or AJAX, and we can set a parameter called with credentials. And this basically says whether you want to send cookies or not. So if I send a request for something from JavaScript and I set with credentials to true, then I might expect this to always work, because if it's a server that I trust, that's fine, I can send cookies and I don't care. And if the server needs the cookies, it'll use them, and if it doesn't need them, then who cares? It doesn't matter. Actually, it does, because if the server doesn't emit a header that says it wants the cookies, then the browser will actually not allow you to see the response, because it's not compatible with the CORS policy. And it won't give you a specific error to tell you exactly why, it will just look like a network failure. So that's really bad, because now we just have to guess why this request failed and then retry the request in the opposite credentials mode, and then it might work. And if it works, we know that was the problem. So there's various arguments which I don't entirely understand about why the current way of doing things is a good idea, and I don't know what the solution to this is. Is it the blockchain? No, probably not. I think the best thing for everyone to do, if you want to have good practices for security headers, is head to securityheaders.io. This is nothing to do with me. It's nothing to do with Fastly. But it does give you some pretty good advice about all of these things. And it will tell you if your CORS policy looks as though it's too lenient. So from security onto performance and the link header. Now, the link header actually is pretty venerable. It came along with the very first version of HTTP 1.1 in 1997, but the preload variant has only been recently added. And the link header was originally designed as a semantic link to resources that were related to the current page. So let's say you were reading a book and you were looking at a page that was a chapter of a book. Then you would have link headers that would link you to the previous chapter, the next chapter, and the table of contents. Now, we don't really use the web in that way today, which is a bit of a shame. But we can use the link header for other things, like telling the browser about fonts and styles that it's going to need for this page, but which it won't discover for a long time, particularly fonts, because if you think about it, you serve an HTML page. That HTML page, somewhere in it has a style sheet. That style sheet, somewhere in it, has a font declaration. And then the browser might even then decide not to load the font file until it can prove that that font is being used to render characters on the page. So the user might end up looking at a page of blank for quite a long time. And we've all experienced that, and that's really annoying, because we know that the browser has the text, but it won't show it to us because it doesn't have the font yet. So this is a good way of telling the browser to load the font earlier to try and avoid those flashes of blank text, unstyled text. Now, Adi Osmani from Google did a case study on Perf Calendar a couple of years ago about this, and this is a demonstration of applying this to the Tinder website. So you can see that before the tags were added, we finish loading the web page here at 200 milliseconds, but we don't start loading the JavaScript until almost a second. Whereas afterwards, we finish loading the page at 200, and then we immediately start loading all of the JavaScript. And that's the advantage of telling the browser, you're definitely going to need these resources, please load them. My colleague Patrick Hammond actually has a very good talk, which he first presented at CSSConf last year about optimizing for the first meaningful paint, which we also heard the importance of earlier in this conference. And so he does a deep dive on some of that stuff, which I would recommend. The problem with the link preload header, though, is that it has to be sent after the status code has been received. So for some of us, that preload is still too late. There's still an opportunity to use time, which is currently not used efficiently. Let me show you what I mean. Whoops. So let's say you want to go to CNN.com. So you type in CNN.com, and the first thing we do is a DNS lookup. And then we negotiate a TLS connection. And there's nothing else we can do during that time, so that's fine. But then we have all of this time here when the server is just thinking about stuff. And it's deciding whether your request is going to be successful or not. It's deciding whether it's going to be a 200 or a 404, or any of the other possible HTTP response codes. And then once we know that it's a 200 OK, we can send some headers. We can still take some more time on the server if we want to, but the browser now has the opportunity to start preloading resources, which is what it can do here. But what if we could tell the browser to start preloading resources before we send a status code? And that's the purpose of a new standard called Early Hints, which we're working on at Fastly and with various others in the standards community. This is not supported by anything yet, and it requires both browser and server support, so don't expect it to come anytime soon. But if it is implemented, then it will look something like this. You will be able to return 2 status lines for an HTTP response. The first one will say 103 early hints and will provide some headers, and the second one will then provide the final HTTP status code. The advantage of this is kind of obvious. We can immediately respond without doing any thinking whatsoever with an early hints response and some headers. And those headers are likely to be link rel preload headers that allow the browser to start downloading stuff straight away. Then later we can respond with the full HTTP response code and all of the headers that we want to return. So I want to finish with a couple of really exciting potential header proposals which are not yet supported. One of them is feature policy, which is starting to ship in Chrome in a very embryonic way. And feature policy is really a framework. It's an architecture for defining feature names, which are coming soon. And the idea is that using these feature names, you can turn on or off features of the web that maybe you don't want. We're now in a situation where the web can do extraordinary things, like the vibration API, or the USB API, or the Bluetooth API. Do you really want to have to police your dev team to make sure that they don't do anything crazy with these APIs by accident? It might be better just to reduce the attack surface on your site and reduce the amount of, just reduce the surface that you have to deal with by turning off the features that you don't use. And that's the purpose of feature policy. So initially, the feature policies that will be defined are those that are attached to user consent requirements. So any feature of the web, which if you were to use it, would pop up a user consent dialog. This website wants to use your microphone and this microphone and camera. This website wants to know your location. This website wants to send you notifications. These sort of really annoying pop-ups that we get all the time, those will have features within feature policy, and you can turn them off to make sure that, say, an advertiser or any other kind of third-party site that you are importing a script from doesn't activate those APIs. The other thing that we could do with this, though, is quite interesting. We could turn off all of the stuff that was a bad idea. Like, document.write, we've been trying to kill off that API for ages. What if you could just write a feature policy that says, this API no longer exists on my website? So if you do have some kind of third-party script that has that requirement, and it's very hard for you to stop teams that you don't control from using these APIs, now you can just turn it off. And you could potentially use this for all sorts of things like synchronous XHR, or you could use it for synchronous resource loads. Then you wouldn't even need to bother putting defer and async on your script tags because they would just be deferred and asynced anyway. This is really cool, and I'm very excited about it. And everybody else should be very excited about it too. And you should be campaigning for the features that you want to guard to go into feature policy. So do go and have a look at it. The other thing that I like about feature policy is that it provides a potential standards future for proprietary systems like AMP, which is Google's platform for hosting content within search. And so feature policy is one of the things which the AMP team have called out as a requirement before AMP can move to a standards solution. So the final header I want to mention today is origin policy. And you might be thinking, having seen this huge list of headers, that, well, we started with this, and now we have this, and, ooh, I need to bin this clicker and buy a new one. We now have this, and I haven't really given you any reason to think that this is getting any shorter. In fact, if anything, it is getting longer. So we maybe need a solution that allows us to move some of these headers somewhere else. And interestingly, a lot of these headers actually don't relate specifically to this HTTP response, which is interesting because the whole point of headers is that they are metadata for the response body which comes after them. But some of them are just hijacking this mechanism to set some kind of origin-wide policy. Like, for example, strict transport security automatically applies to your entire origin, even if you just hook it onto one single HTTP response and then never mention it again. The browser will still activate HSTS for your entire origin. So we really need a mechanism whereby we can set policies like this origin-wide without having to repeat them on every single HTTP response. So the proposal within origin policy is that we have a JSON file in which you can define all of these header values. And potentially, this is kind of retrofitting around the idea of headers, but we could also have things that are native to origin policy which don't pretend to be HTTP headers. And you can override these by sending the headers in the response itself. But if you didn't override them, then your response is going to be much shorter. It's going to look much more like HTTP responses of old, just a content length, a content type, and a reference to an origin policy. So I've covered quite a lot of headers today. This isn't my attempt at a bit of a recap. I'm no emoji expert, but I thought I needed to put some emoji in, so there you go. Some of them are things that you need to be thinking about getting rid of. Some of them you should go back and add if you don't have them already. And some you can start to get excited about, but not use them yet. And if you're interested in learning about even more headers, then I can recommend this blog post, which I wrote on our blog, the headers we don't want, and there's a link at the bottom there to the second part, headers we do want, because it was so long that marketing told me I had to split it into two. And so that is all I have to tell you about today. Thank you very much for listening.